A rack and pinion is an actuation method where the rotary motion of the motor is converted into linear motion. The circular gear, known as the pinion, rotates and interacts with the linear gear, known as the rack. Rack and pinion systems have a variety of applications to them. One of their most common uses is in cars, where the rotational motion of the steering wheel is transferred to linear motion on the driving wheels. For a VEX robot though, the rack and pinion design can be used to create a lift that will allow you to elevate your robot off the ground. This mechanism will make any team more versatile and successful in their matches. To prove that our guide was effective for even those inexperienced with VEX, we asked our friend with minimal robotics experience to follow our instruction guide with no outside assistance to prove its standalone functionality.
Our friend starts off with installing the outer slide trucks onto a C channel. By implementing intuitive CAD models onto each step as well as including additional tips when necessary, he was able to complete this first step with ease. Make sure to align the trucks properly to minimize friction with the linear slide rail. This will result in a more efficient mechanism. After that, he moved on to constructing the moving arm of the build. Remember to place nylock nuts into the rack gears before placing them down and screwing them in.
The 5x10 steel plate was pre-bent in order to save time, but we included a helpful video link on the guide for tips on how to bend it yourselves. After finishing the claw portion, he moves on to the motorized gear portion of the design. Make sure a metal shaft insert is present in the motor before screwing the motor in. Also, don't forget to leave a metal shaft cowle in between the motor and C channel. When attaching the rack to the motorized gear portion, make sure to screw in the C channels as parallel as possible. We found it easiest to alternate the side we installed each screw, but complete this step however you see fit.
Install a 1 3/4 inch screw near the bottom of the design. This will ensure that the slide rail will not fall out of the slide trucks. Our friend here has made that mistake of putting the standoff attached to the slide rail underneath it instead of above the screw. But luckily, it's not hard to fix if you mess up. Just unscrew the long screw, move the rail forward, and rescrew the long screw in if you make this mistake.
And that's the end of the build. Although this video only shows the left claw portion of the guide being built, the right claw portion of the lift is the same but mirrored over. In addition, when installing the lift onto your robot, ensure that there are 2 points of contact present. The angle gusset acts as 1 point of contact, but we suggest attaching the back of the claw to a cross member on your robot as the second point of contact. This will help with the claw's stability and structure.
Our final 3 tips are related to coating the lift. Firstly, set the velocity percentage to 100% and the motor stopping to hold. This will make controlling lift faster and be able to hold its position. Secondly, create blocks to represent 2 buttons to move the lifts forward and backwards respectively. Finally, add a weight block to the code for each button that stops the motors when the button is not pressed.
That concludes our build instruction guide. We hope that you find this guide useful in your future VEX endeavors. Thank you for watching.